Hello students, welcome. This is the video on chapter 5, one of the videos, and this is for section 5.9. See, in here we will define elasticity and learn about the calculus behind this elasticity concept. So elasticity is defined as what? Is defined as proportionate change in quantity divided by proportionate change in price. So you see that is what? That is, in the numerator we have a proportionate change and the variable quantity. In the denominator we also have a proportionate change, which is price, right? And this ratio called elasticity, and this will tell us how much this quantity will change when price changes by 1%. We will show you. Now the basic formula for calculating elasticity for a demand or supply function. Demand, we can have measured if this is demand, quantity demanded, then this we can measure it. This is elasticity of demand. If this one is supply, then it will be elasticity of supply, right? Basic formula. So for this one is given as quantity demanded depend on price. See, remember law of demand. We said if price increases, demand will decrease, and vice versa. Other things remaining unchanged, or that ceteris paribus assumption. So that is elasticity of demand. Now, if you want elasticity of supply, then this will be law of supply, which says that quantity supplied of something will increase when price of that increases, and vice versa. Again, other things that also affect supply remain unchanged. That ceteris paribus assumption, that other things remaining unchanged, is important. Now elasticity, then in here, from here we can, in notation we can write it like this, right? So this one is telling us that change in quantity delta Q, right, divided by quantity, and change in price divided by price, right? So that one, so that is the ratio that tells us, that gives us elasticity. Now in section 4.2 we notice that in the previous section, chapter 4, that the formula gives different elasticities for the same change depending on the direction in which it takes place, and we define a measurement known as arc elasticity as one way of overcoming the problem, right? In another video we will show you that. Now, since demand and supply functions are usually drawn as smooth curves, a neater and more general approach is to find point elasticity. See, so because these are, we often draw demand and supply as straight lines, right? So we go for point elasticity, remembering the rule that that when an expression is divided by a fraction, we can turn this fraction upside down and multiply by it. So we can rewrite the formula. So here is expression, this numerator, this proportionate change in quantity divided by price, divided by proportionate change in price, but this itself is a fraction. So if we bring it up and multiply it, it will become what? It will become just flip, right? So this one will then become this change in quantity divided by quantity times, this will flip, price divided by change in price. If we bring it to the numerator, then we simplify change in Q over change in P, okay? Then P divided by Q. See that? We just take it here and bring delta P here, and we get the result. So that is the result they have here. So this now is elasticity. To calculate point elasticity for the function, this one Q is a function of f of P, we replace that delta Q over delta P with the with dP dQ over dP. See, this is the derivative, where dQ dP is the derivative of quantity demanded or supplied with respect to price, right? We are differentiating with respect to price. Okay, now we continue, right? So we continue. This is point elasticity that we did last time, right? So let me see if I can take a pen. Okay. So now let us see. Okay. So point elasticity, as we have discussed, is this one from last class. Now this one is that to find price elasticity of demand using formula, we work with the equation for the demand curve, right? So as we said, right, here then q it is a function of price p. If we are working, so this will be demand equation, demand curve. We differentiate it with respect to delta dq over dp, so get this term, and then substitute and appropriate as appropriate. On the other hand, if we are talking about supply elasticity is found from the supply equation in a similar way. So that will be supply curve, supply depend also on price, right? So this is from law of supply, this is from law of demand. Now, if the now let us say if the demand or supply curve is equation is given to us in the form that q depends on as price of p, differentiate with respect to p gives us delta p q over delta p, the derivative we require for to calculate elasticity. If instead the function is given us in the as p is a function of gq, right, g of q, the easiest way to find the delta q delta p will be to differentiate this with respect to q and obtain dp over dq. See, just differentiate this and obtain dq over dp, dp over dq, and then what, use the inverse function rule as we have discussed in one of our previous videos for this chapter, and take dq over dp, right? Just take the inverse and that will give us the result. So by the inverse function rule, they are telling us that dq over dp is equal to 1 over dp over dq, right? So even if the function is given in this way, that is not a problem for us to when we try to find elasticity. Okay. Now let us see. We continue, right? This is page 215. We continue, and this is differentiation. Say, suppose that the demand in a certain market is given by q equal to 32 minus p minus 4p. See that? So we said before that q was a function of p, right? And if p changes, q will also change. And for law of demand, we said that if price increases, quantity demanded will decrease, vice versa. And this is the equation exactly we have for this problem. Now 32 is the intercept and minus 4 is the slope, right? Now they are asking us calculate the point elasticity of demand at the following prices. When p equal to 8, what will be the price elasticity of demand, right? So let us see. So we begin now calculate elasticities for the demand curve. This is another demand curve. See that intercept 80 and slope is 12 at prices 6 and 4. Sketch the three curves and say how their elasticities compare, right? So the three curves. So let us see. Let us compare. We begin by defining dq over dp for the first demand curve. It is given by, we differentiate, right? We differentiate this one and get that minus p. You know that 32 is 0. 32 is a constant, so it will become 0 when we differentiate with p. And this minus 4p, when we differentiate, that will p will become 1. This is the power function rule we discussed before. So we just have 1 multiplied by minus 4 is just minus 4. And that is what we have here. Now, using the definition of the point elasticity, we know that what? This is the definition of point elasticity, and we already solved for that for the first fraction, right? dq over dp is minus 4, and now all we have to do is to substitute P and Q in this equation and then get the results that we want. And now they are saying that when P is 8, Q is 0. How do they get it? Let us show you. If here they are telling us, right, calculate elasticity at following prices. First $8. So if P is equal to 8, right? If that is the price, then what is Q? Let us substitute. Is what? 32 minus 4 times what? P is 8, right? We are just substituting value. So 32 minus 32 is how much? Is 0. That is Q. See that? So Q is 0. Then what about P is equal to 6? What is Q? What is demand when price? So let us solve that here. If P equal to what? P equal to 6, right? Now again substitute this in the demand function here, right? So Q will be equal to 32 minus 4, and then P is what? 6, right? So this is 32 minus 24 is equal to what? Is equal to, if you do the math, you will see this is Q equal to 8. See that? So we have this 8. That is the result. Okay. Now and similarly we go until when P is 0, we go that Q is 32, right? We go and now what happens? Now again and again this P and Q we will now solve. So let us see, well, what is elasticity of demand? What is elasticity of demand when P equal to 8 and Q equal to 0? That pair, right? Pair, this one. So what will be elasticity of demand? So we know that that this part we already have solved, minus 4, right? And then P we are saying is 8 and Q we are saying is 0. So minus 4 times 8 is minus certain divided by 0. Anything divided by 0 is what? Anything divided by 0 is infinity. Okay, that we already know, right? Anything divided by 0 is infinity because 0 has nothing in it. So if you divide, you continue to divide again and again with nothing, and you can go until infinity. So this is the first part. Here they have infinity, right? Okay. Now what about the second one? If the second pair, this one, let us calculate, right? So let us go this side. P equal to 6 and what? Q equal to what? Q equal to 8. And what is elasticity now? Let us try now. So this is what? Minus 4, right? Here minus 4. And then what? P is 6 and Q is 8. So let us now, 4 and 8 is what? 2. 2 and 6 is 3. So it is going to be minus 3, right? Minus 3. So you can see here this is minus 3. Okay, minus 3. And now what happens? So that is one thing. And now so we can do repeat this again and again, and now by now you have the idea. You can generate all these values, this minus 1, minus 1 over 3 and 0. Those will be the elasticities for those combination, that price and that quantity, right? We have to follow the pair. If you are checking with P equal to 8, you have to go with the pair Q equal to 0, and so on for all the other pairs, right? Okay. So you see, so this we go to the next picture. So we already did this, and we already have this result, right? In the previous picture, this table was almost cut off, but now we can see it clearly. Now, so that is one. That was the answer for the previous problem. Now they give us a new equation. Suppose what? Q equal to 64 minus 8P. That is the new demand equation. And based on this, we then have to find the new elasticity for the same pair. So let us see. First, let us analyze. Let us now differentiate that dq with dp. We get what? Minus 8. See that? So this one minus 8 we have, and then and then let us see what is the elasticity now with this pair, right? So elasticity, let us go to this elasticity formula. All of this we have just shown to you. Differentiate and get this with p and get -8 here, -8, and then p times p divided by q. So let us try. P is 8 and q is 0. If you try, you will get elasticity again. Again, if you put 6 and 16, p is 6 and q is 16, you divide, you get -3 again. So let us see, let us try that one. So what we are saying is that we want to measure elasticity such that price is equal to 6, this one, right, and quantity equal to 16, right? So let us try, let us now try. This is what, -8, and then price is what, 6, and quantity is what, quantity is 16. So if you now divide this one with 3 and this one with 3 and this one with 8, then 8 you can cancel, so answer is -3. See, elasticity for there, that were here, this one. Okay, all right. Now, so this similarly you can get all the other elasticities in this way, right? Remember, again and again you will use this -8 from here when you differentiate this equation, and substitute for the values of p and q. So when you take p4, substitute q32, take p2, substitute q48, right? Now we compare the demand curve. Now let us change the demand curve again. Look, from here, from this demand curve, now we are just saying this one. For this curve, differentiate this with p is -12, right? It was -8 here, but when the curve changes, this is our new value, right? And now calculate elasticities as before at the specified prices. So price will be 8, price will be 8, and find out q and use that. Price will be 6, and so substitute 6 here and find out q and use that to calculate elasticity. Again and again, dq and dp will be -12. Okay, so hello students, here we are showing you with the graph, right? Now let us see, what did we say? We said that the let me see if I can make it a little bit bigger. Okay, so let us see. So the curve is more elastic than other curves at the same price. Before we go there, let us see what is going on. We said that how do we get those curves, right? That is the question I first want to answer for you. So this, that q equal to what? The first equation was 32 minus what? -4p, that one. So which one is that equation here? So to get that, to find the graph of this equation, let us use this trick. If let us say q equal to 0, what is p? If q equal to 0, then this means 0 equal to 32 minus 4p. See that? And now 4p, we take it on the other side, minus, be positive, negative becomes positive, and 32. So we simplify now. P 32 divided by 4 is how much? Price is what? Is 8. See that? So this is a combination, a 0 and 8, right? And be careful. P we are plotting vertical axis, and Q we are plotting in the horizontal axis. So the in the Cartesian geometry, Cartesian plane, this horizontal will come first, which is in this case q is 0, and at that q equal to 0, price is, corresponding price is 8, and this point will be on this straight line. On the other hand, to get another point on the straight line, right, to identify the straight line with this curve, we need 2 points. So this is the second point. We already have the first point right here. This is the first one. The second point is what? P, so let us say P equal to 0 and then now solve for Q. Q equal to what? We know that 32 minus 4P, and now we must put what? We are looking for Q that correspond to P equal to 0. So this is 0, see? So Q equal to what? 32. So that one, 32, 32 and price is 0. This is another point. This is another point on the graph. So this is point 2. So we have point 1 and point 2. We have point 1 and point 2. So now what are we doing? So let us see if I can change the ink color, right? So this is 1 and this is 2. We now want to plot. Now this one, 32, Q is 32 and P is 0. This is this point. See that? 32, Q is 32 and 0. This P axis is 0 means the point sits on the horizontal axis. So this corner point. On the other hand, what about this? Q is 0 means that the horizontal coordinate 0 means that this point 1 will be somewhere on the vertical axis at P equal to 8, this one. So see, this is the equation for number. This is the line, this line is then the what? Equation for number 1. And you can see all the other points, 6, 4, 2, if you go and compare with your results in the previous slide, correspond to this one, okay? This is equation for D1. So D1 is what? This is the D1 equation. This is how we find. Now what about D1? What about D2? D2 is the second equation. Remember D2 we said that what is 64 minus 4P. D2 was the second equation. So let us see. No, 64 minus 8P. It was 8P. That was the equation, and this is for D2. If you plot it in the same way, right? First, let us say Q equal to 0 and then find P. On next, when you solve that, then find P equal to 0 and find what is Q. So you'll have one pair here, one pair here, and if you plot it, you will see that D2 will be like this one, right? That is one point. This is another point, right? And you add them together, and you get your answer, right? Okay. Because I'm drawing freehand, so you see my lines not straight, but with the color you can see this straight line, right? D2. Now D3, then will be what? D3, the D3 will then be what? D3 will be the equation what? That is Q equal to what? Q equal to 80 minus 12P. See that? 80 minus 12P. Okay, so now, so that one we have. So you can now see that this is what? This one, right? That one, D3 equation. So you see we have what? We have different lines, different demand curve for different equation. In the graph and also in the equation they are different. And okay, now let us see what happens. This curve is more elastic than the other curves at the same prices. So which means what? This is for D3. See, for D3 is flatter. D3 is flatter means that if you compare when price changes, quantity will change more. For D3, this change will be bigger for the same change in this compared to the other lines. D1, D2, D3, this change will be bigger. Now this change in the quantity is actually in the numerator of the elasticity formula. Then elasticity will be higher, right? So for example, at a price of 4, the first two demand curves have elasticity equal to 1, but the third demand curve has elasticity equal to 1 equal to minus 1.5. See, the reason for this is that third demand curve has higher value intercept on the has lower value intercept on the p-axis here, this one. The reason for this is that the third demand curve has a lower value intercept on the p-axis. This curve is shown as D3 in the graph, so as we have said, right? So okay,